with the new 800 amp IGBTs I put in, I got, bought a bunch from an eBay seller called Fictron. I don't know if this is one of those or not. You can tell some of them, like this one. This is an original 800 amp IGBT, and it's got the old label. It's been used, but it still works. This is a good one. I blew up a bunch of these when I was in my early testing with the controller. The 600 amp IGBTs I pulled out, they have those old labels on them, and they're also good ones if this will ever focus. Essentially, because these are good 600 amp IGBTs, they run pretty good. They produce a decent amount of power. What happened was when I put these newer ones in, they have this fancy new label, and they're labeled as new on the website, eBay when you buy them from Fictron. They're about 140 Canadian each or something, maybe 150, I can't remember. It's, he's a reputable seller on eBay and everything, but if you were to try and go to Octopart or whatever that website is, the cheapest ones they can find you are like $600 Canadian or something each. So trying to do what I can to find a deal on them. Now I'm fine with buying used IGBTs out of Germany. In fact, I ordered 7 this morning from one of the forum members off a do-it-yourself electric car. Actually pointed out he can find a few there, so I ordered what I could find on eBay this morning. Hopefully they're actually used, or sometimes they call them refurbished, and I think that just means they measured them, made sure they're not shorted or anything. And nonetheless, I believe what's happened is the Fictron IGBTs off eBay are counterfeit. Now the funny thing is I could call them a good counterfeit, not a great counterfeit, and I'll go over that. But the car, like what I've done recently, the car is actually hauls ass. It does really good, but it did better with the 600 amp IGBTs, and that doesn't make any sense. So when you go into the data sheets, you look at all the data between the 600, like this is a 600 amp IGBT, its voltage drop at say, like right now I did some double pulse tests, and I'll go over that in a minute, up to 1200 amps with about 14 volts applied to the gate. That should be around, on a 600 amp IGBT, that should be around 2.75, maybe even as much as 3 volts, in that ballpark right there, before it trips the DSAT. And so I'll click and then if you're on an 800 amp IGBT, 1200 amps would only be like, probably somewhere around 2.25 to 2.5 volts, in that ballpark, for voltage drop across IGBT. So I did a quick measurement. I checked what the DSAT pin was producing, and in the tests on the DSAT pin with the Zener diode and the other diode in series, it's giving me about 2.68 to 2.84 volts, depending on which test I did, at the DSAT pin with no current flowing. So that means I have roughly somewhere around 3.65 volts drop when it's desaturating at, I just did some tests, it's desaturating at 1220 amps. Now, knowing that means it's about 3.65 volts drop across IGBT itself. That means it's somewhere over here for some reason, and they're claimed to be 800 amp IGBTs. Now this is the 25-degree window, as you can see there. This one's 125 mile. I'm doing it at like probably 18 degrees shop temperature, so we're going to go with this one because the controller's not hot. I'm doing one single test, measuring it with the oscilloscope, and I'm not seeing what I'm supposed to see. So essentially it's somewhere over here, which doesn't coincide with what this IGBT is supposed to be at all. Even going to the 600 amp IGBT, and this makes sense because the 600 amp IGBT let me turn the power higher before tripping the DSAT. It would still be over here, which is out the window, because it's about 14 volts at the gate when it trips. So it's somewhere in this window where it should be. So even with the 600 amp IGBT, it's still giving me half a volt too much voltage drop at the IGBT itself, maybe even a little more. So genuine, even if they're used, IGBTs would probably solve this big time, would get me back to here. And then having said that, the circuit is set up to trip over 2000 amps, which is about ideal because I want to be peaks of somewhere around just over 1000 RMS, approaching 800. So that all works out to, you usually just basically take your peaks, so your RMS, divide by 0.707 I believe it is, and then you double it. So basically you just take your peaks and you double it for what you want to set your DSAT to trip at, which would be somewhere around, you know, might be up here somewhere over 2000 amps anyway. But it's what you, if you look at this chart, no matter what voltage you apply to your gate, all of these will eventually go up and then curve over. No matter what voltage you're putting at the gate, at some point they curve over, and that's this curve right here is what they call where IGBTs become desaturated. It's just no longer able to flow any more current, and no matter what you do, any more current, it just becomes a straight line sideways where it just becomes more and more voltage drop no matter what you do. Nonetheless, I'm pretty sure I've proven that these are counterfeit IGBTs. I even tried upping the voltage to the gate from 14 volts after a long on pulse to 15.4, and it didn't help one single bit, just to double check that maybe I was like over here in a weird area where it's not enough voltage, but no, that's not the case. And I was going to change my DSAT Zener out to a different value to get this number lower, but when I saw how low that was already, I've already got that tuned really good. My gate's also switching pretty clean. We can look at that here a little bit. So these pulses here, like this is supposed to be a double pulse, and if you look at it, the setup I have here is only supposed to send 2 pulses, but you can see the 2 like an extra pulse in there. What that is it's desaturated right about here. Like this is a current trace at the top. This other green trace is actually the voltage across the IGBT, and this lower yellow trace is the gate voltage, and you can see that's the gate signal. Basically it's desaturated, so the driver, the FET driver, said, hey, we got to shut down. It shuts itself down and it waits the 25 microseconds and tries over again. So nonetheless, it tried twice, and the gate switching looks pretty clean. Like it's not perfectly amazing, but it's really not going anywhere dangerous. Like you don't see any spikes or anything off that. So it's nothing to do with that. It's all simply to do with the fact that there's too much voltage drop across the IGBT itself. Now I tried measuring the voltage drop because I'm actually measuring across the high side IGBT, and that's the one I'm pulsing, and that's the green chase, but it measures out to be like 16.4 volts. I think what that is I believe what that is the fact that where I'm able to probe has to go through a few pieces of aluminum bus bar, so there's a bit of voltage drop in the actual bus bar or whatever. That's a hard thing to measure accurately, but nonetheless, zoom back in. Nonetheless, what I'm actually going to do, oh, and this purple trace, or whatever color that is, that represents about 1220 amps. I've measured that, so that's using the current sensor that's in the system. Now, coming back to that, so that 1220 amps means I only should be running around peaks of 600 amps, which makes about sense. It makes rough sense because I'm not able to turn it up, which I have the peak amp set to 750, but I'm not able to turn it up to run that 750 amps. I'm only able to run with the dial turned down maybe 650, 700 peak amps, and that works out to be right in the ballpark of where it should be. So that all makes sense, you know. 650 doubled would be 1300, and I'm able to hit 1220, so that's, you know, pretty close to what it actually should be tripping at. Nonetheless, basically the answer is going to be different IGBTs. 120 amps it worked out to be. You can see the 2 pulses at then there. It's only supposed to be 1 long pulse and then 1 quick pulse after that to let me study what the gate switching looks like under load. Nonetheless, did some more digging at it, and I noticed that what it appeared to be, the Miller plateau here, is actually up around 8 volts when it should be down around 6.5 volts, 7 volts max. Did some more testing, more testing. Got set up. I set up myself a little jig here and basically just took an IGBT, and I labeled one somewhere, but nonetheless, I took my 600 amp IGBTs and I took all my 800 amp IGBTs and I hooked them up, and I did a few tests where I put 5 amps current through that heat dish from 100 volts. I found that the gate had to be about half a volt to a volt higher under load to turn on the fake counterfeit, we'll call them IGBTs. With the quality, I have 4 quality 800 amp non-counterfeit IGBTs, I figure, because I was able to turn the gate on at 6.6 volt where it started to turn the heat dish on. And so I did another test to try and figure out a way to figure out if I could do it without even putting load on it. And what I did was I hooked up this multimeter, put it on the diode check mode, hooked it across a IGBT, which we can do with one of these counterfeit models, and I basically just got it set up quick. It actually doesn't take any time at all. I can do it while we're on video. I'll put the negative here, and I even wrote this one 7.1. Just got to get these untangled a little bit. The 7.1 means under load it took 7.1 volts before it turned on. And then I have these two here for powering the gate. Got all kinds of vehicles partying outside, doing all kinds of stuff. Everybody thinks they need a diesel around here. Nobody has a clue what's a good vehicle around here. Nonetheless, turn that on. We're at 5.56. It's not on. What I do, I actually normally don't even have it set that high. I'll bring this up until that starts. I'll just turn in my fine tuning dial here in the middle. It's at 5.52 right now. I'm going to slowly turn it up till that turns, till I see some voltage drop there. And I'm betting we're like in 6.5 something. There it is. So I'll go back till it goes off again, come back till it comes on really slowly, and right there we're at 6.37 volts, where it actually just started to turn the gate on this counterfeit IGBT. So now what I'll do is I'll just turn that back off, the voltage back off, and we'll go get a genuine 600 amp IGBT here, which I believe this one to be one. There's a couple things you can notice that are different about it. This is a good one. These are actually all out of the car, and they did really good. So I can grab any one of these, and it'll work for this test. I just got to clean them off, because I'm going to use these for other controllers down the road. Then, like, the car hauls ass. Like, you can do some pretty amazing stuff with a 600 amp IGBT in these things. Try and get these hooked up decent. It's a little tricky with these alligator clips here. Kind of a pain in the ass, really. I want to get some that are a little better silicone rubber. See if that'll stay on there. Nope. Just wants to be a bugger today. Okay, so now I got that set up. So basically, I'm going to bring this up to around 5. Make sure the middle's turned down. Ah, Jesus. Make sure the middle's turned down so that I can. The middle dial is the fine tune adjusting dial. I just wanted it turned down so I can. Oh, I'll bring it back down. So, might be able to get this all in one picture. I don't know. Probably not. Yeah, it's too tricky. Just about. Try that maybe. Get the glare out. It should come on any moment now. There it is. Look at how it's at 5.39. I'll go back till it goes off again. Come back slowly. Yeah, 5.4. So the voltage applied to the gate with the good quality 600 and 800 amp IGBTs is about 5.4 when it becomes just starts to turn on with the multimeter testing on the diode check mode. So that was a quick test to prove that. Yeah, so that's pretty annoying. What I've done right now is I've actually rebuilt it with I put 2 in the middle, 600 amp IGBTs, and the outside 4 are what I believe to be trustworthy quality 800 amp IGBTs. And I have 7 more on order from a company in Germany that sells them on eBay. The problem is when you order the quality new replacements, like if you go to Octopart or whatever, it's like $600 Canadian per IGBT. These 600 amp IGBTs, I get them for 30 to 40 bucks US, usually from eBay. Pretty frustrating. My first 7 I got that I blew up, which are laying there on the floor, plus one that's a counterfeit, I believe. The first 7 that I got, I blew them up from all my testing. I had to change my current limiting resistor in the DSAT circuit from a 100 ohm to a 1000 ohm, and that was most of the solution. I'm just looking for a last counterfeit IGBT. I was going to pop one open while we have the video going, just because the other thing I noticed, I have one that should be clean. Probably put it right here. Yeah, I put fake. If you, stupid camera would focus. Anyways, I scribbled fake on there. Yeah, what I wanted to do though was compare that writing. If you compare the writing, you can see how the fake one, this is the same when you compare the fake one to an 800 amp. The F and the E at the start are a little smudged looking, and all the barcode isn't as fine. It's all fatter little numbers. You can definitely tell it's fake. So the other thing we can do, and this is a fun little part, let's bring it over here, do this on video quick. It's pretty easy to do. Got the wrong screwdriver. Just pry these, what you do is you pry these little tabs up, and you get them basically straight up, all of these tabs. And I don't really care with this one because it is a fake. Now, when I say fake, don't get me wrong, with 5 of these fake ones in and 1 quality one in, essentially you're still flowing. Like, that's what I was running when I had fun last weekend. I was running 5 fake counterfeit IGBTs in there, and it was just tripping DSAT. I couldn't get the power that I wanted, but the car was still fast. I was able to get 230 kilowatts peak, and I was also able to put about 650 to 700 peak phase amps in, whereas normally I can put something more like 750, 800 with the 600 amp rated IGBTs, and that's peak. And I figure I should be able to peak over 1,000 probably with the 800 amp quality IGBTs. Now, what I just did there is I popped the cover off because you can actually see inside. These are this one right here is probably a decent one to compare to. This one and this one, they're kind of clean-ish. If you look inside, you can see the main chips. They're actually a little different. If this thing will focus. Give it a second here. There we go. So you can see the fake one, the chip looks quite a bit different down inside there. So we'll spin that around so it's kind of the same way around, but you can see that chip on the genuine one and that chip on the fake one. Another thing, they look very similar and everything, but what's missing here? What about trying to stop water and the elements from getting in there? This one has a gasket, and the covers on the genuine ones don't come off. Like, I just pulled that off. They're actually like glued on there. They're really hard to get off typically. So there's a couple little examples of how to know when they're fake. Either way, have more coming. Have it going back together, so it should run good for the next couple weeks. They're coming from Germany, so I figured I'd put it together and try the new code Lebowski has out. But it's kind of exciting to find this, and at the same time it's frustrating because I know there's lots of these quality ones out there, especially when they pull them out of UPS or whatever, they pull them out of data center power places or whatever over in Germany, because they have to cycle them out. I'm sure there's tons that are floating around over there going in the garbage, whatever. It'd be nice to get my hands on another 10 or 20 of them, because I could build a lot of fun stuff with them.